Alright, so welcome to part 2 of exploring Newton's laws. Let's look at questions 13 and 15 here. Start with 13. A 1,300 kilogram car travels at a speed of 10 meters per second when it strikes a tree. As a car's frame collapses, it is brought to a complete rest in 0.1 seconds. What force was applied to the car by the tree? So let's do our guess method. What's given to us here? Well, we know that the mass of the car is 1,300 kilograms. We know that the initial velocity of the car is 10 meters per second, and we know the time it takes to come to a rest is 0.1 seconds. And then our unknown would be force. We do not know the force on the car from the tree. All right, so let's come up with an equation. Force is equal to mass times acceleration. All right, so we know the mass, 1,300 kilograms, but we don't know the acceleration. So we need another formula to help us solve for acceleration. So remember that acceleration is equal to change in velocity divided by time. So here's that equation, change in velocity divided by time. Remember that we figure change in velocity by going final velocity minus initial velocity divided by time. So if we read through our problem, it says it's at an initial speed of 10 meters per second, and it hits that tree. So then we assume that the final velocity is going to be 0 meters per second. So there's an extra piece of information that we need to put in here. So let's plug in our numbers and we can find the acceleration. The final velocity being 0 meters per second, the initial velocity being 10 meters per second, divided by our time, 0.1 seconds. Alright, so that gives us negative 10 divided by 0.1, which is negative 100. So there's our acceleration. So now we can plug in a number to acceleration. So force is equal to mass, 1,300 kilograms, times our acceleration, negative 100. So 1,300 multiplied by negative 100 is going to give us negative 130,000 newtons of force. That's an extremely large force. Hitting trees with your car is typically really bad. Alright, so let's go to problem 15 reads, a 5 kilogram cart rolls without friction to the right with a velocity of positive 80 meters per second. A force of negative 35 newtons to the left is to the left, that's in the negative direction, is applied to the cart for 2 seconds. What is the velocity of the cart when this force is removed? So let's go through our guess method again. Our givens here, we know the mass is 5 kilograms. It has a velocity of 80 meters per second. It has a force of negative 35 newtons. And a time of 2 seconds. Alright, so then unknown. Aha, what is the velocity of the cart when the force is removed? So that would be a final velocity. And up here this should be marked initial velocity because it's starting there. So we've got all of our stuff labeled out here in terms of our variables. So let's see if we can figure out an equation that will help us out. Alright, let's start with your equation for force. It's equal to mass times acceleration, but that's not going to help us just yet. Okay, so if we're looking for velocity, we need to go back to final velocity. We need to go back to our kinematics equations, and we'll look for an equation for final velocity that incorporates acceleration and time and initial velocity into it. Okay, so let's see, acceleration multiplied by time plus the initial velocity. Let's use that one. Alright, so then let's start plugging in some numbers, and we might have to use these two equations together. All right, so we need to use these two equations together. What are we missing here in this formula? Well, we've got we're looking for the final velocity. Oh, we don't have acceleration. We have time, and we have the initial velocity. So we need acceleration. So let's use this equation to find that acceleration. So acceleration is equal to force divided by mass. And we've done that already in some previous problems on this sheet. So do we know the force? Yes, we know the force. Do we know the mass? Yes, we know the mass, so we can find the acceleration. So once we know that, then we have enough numbers to plug in here to find the final velocity. So let's start plugging in some numbers. The force being negative 35 newtons and the mass being 5 kilograms. And that gives us an acceleration of negative 7 meters per second squared. So then we can start plugging numbers into this one up here. We'll say velocity is equal to, so let's actually start, this is not an equal sign. Say velocity is equal to the acceleration, which is negative 7 meters per second squared, multiplied by the time. Come over here, the time was 2 seconds, so put in our 2 seconds, plus the initial velocity, which was 80 meters per second. And notice they definitely let us know it's a positive there, so plus 80 in this case. So negative 7 times 2 is negative 14 plus 80. Okay. So this should be 66 meters per second. Negative 14 plus 80 would give us 66. All right, so where do these units come from? Well, it'd be a velocity, so we've got to make sure to put in meters per second right there. All right, so that's how we solve this problem. If you have questions, please let me know. The answers to the other one, to the rest of the problems are here. So go ahead and you can look at these and finish up this homework here. Okay, please come to tutoring if you need help. Hopefully this stuff these problems are getting a little bit, or using these formulas in physics is getting a little bit easier. The more you do them, the easier it gets. Come in for help. We'd love to answer questions, and I hope things are going well for you. Bye.